Hello everyone, welcome to Bosscoder Academy. Today we are going to solve system design of Instagram. This system design is asked a lot in interviews of top product-based companies. So let's discuss, let's solve this. So whenever you are given a system design problem, the very first step that you should do is to gather requirements of the system. For example, Instagram is a very big application. So what are the different features do you see in Instagram? For example, Instagram have where you can share photos. You can also like and comment on posts. You can follow each other, follow pages or follow people. You have a news feed on Instagram. Whenever you open Instagram, you see a scrolling news feed. You can send messages. You can watch reels. You can have stories. You have IGTV, which is kind of a video platform for Instagram, and many more. You can have advertisements and many more. Of course, when you are in an interview setting, you cannot design all of these features in 1 hour of an interview. So it is very important to understand what are you actually designing. So in this video, we are going to talk about how do you design a news feed? How are you going to follow people, not pages, but people, and how can you like and comment on a single post? However, we will not discuss how do you go about sharing photos, messages, reels, stories, IGTV, ads, and many more in this video. However, we plan to cover all of these topics in the future sections of other videos that we are going to upload in a while. So you can consider subscribing us to get updated about those system designs as well. So now with the step 1 of gathering requirements, we are clear that by meaning of designing Instagram, we mean that someone will be able to share post and others will be able to, these are photos post, and others will be able to like and comment on this post and follow people. Also, we are going to support a news feed which is infinite scrolling. This is what it means by us for designing Instagram. Now, once you know what are you actually designing, let's talk about in the step 2 at what scale you are designing. This we cover in scale estimation. So let's do the scale estimation of storage. So what do you think? How many number of users are there on Instagram? So let's say the number of users on Instagram are around 1 billion. Now, of course, on any social media, there are two types of users. One users are content creators and other users are content consumers. What do I mean by content creators? Content creators are people who are creating content on Instagram. Whereas content consumer means that these are people who are consuming content but not really creating content. So on social media and on Instagram specifically, 5% of total users are around content creator and remaining 95% are content consumers, which means that there are around 50 million people who are creating content and then 950 million people are consuming content out of this 1 billion total people that there are. Again, remember, these are just estimations, but they are not actually the right numbers. Now, if there are content creators are 50 million, let's say that they are posting one content every day on an average. Some people might be posting 2 content, 3 content. Some people might not be posting on a day. But let's say on an average, they are posting 1 content every day. So how many posts are getting created every day? 50 million. Now, how does one post look like? A post definitely consists of post ID. A post definitely consists of the creator ID. It definitely consists of the timestamp. It consists of the photo URL, right? The media URL. It creates content, caption content as well, and multiple other things as well. Overall, we can say to store one post, it is taking 1 KB of data or 1 KB of storage. So how much is the total storage requirement per day? So there are 50 million posts getting posted each day, and each post is taking 1 KB of storage, which means around 50 KB into million. Million is a 10 raised to the power 6, which we can write as 10 raised to the power 3 into 10 raised to the power 3. What is a 1000 KB? 1000 KB is a MB. What is a 1000 MB? It is gigabyte. So 50 gigabyte of data per day is getting created on Instagram in just form of text, right? Now, of course, Instagram do not delete old post. So let's say if we are designing the system for 10 years, how much storage requirement will be there? So per day it is 50 GB into 365 days into 10 years. So what is this going to be? 365 into 50, right? Or I can write it as 365 into 100 into 10 by 2, right? I'm just writing 50 as 100 by 2. So if I cut this, this will become 184, something around 184. So it will become 184,000 gigabyte of data, which is 184 terabyte of data per 10 years. This much storage we have to store over the period of 10 years. Of course, this cannot be stored in one database. So later when we talk about design, we will discuss how are we going to store this much huge amount of data. Now, once we are done with storage estimation, let's move to the step 3. The step 3 is, in this step, let's talk about what are the design goals we have. By design goal, I mean, what is the requirement for latency? Do you want your news feed to be loaded fast, or do you want your news feed to be loaded slow? Of course, you want your news feed to be loaded very, very fast. So the requirement for latency is low. That your latency should be low. What about cap theorem? If you don't know cap theorem, we are going to cover cap theorem in the coming videos. So again, you can consider subscribing us and see that video in the next week coming up for cap theorem. For cap theorem, what is important? Consistency is important or availability is important in this case. Of course, if this is Instagram and this is a post by Rajat, and let's say there are 2 users, Manav and Noor. So let's say on actuality on this post, there are 10 likes. But when Manav sees this post, he sees that there are 9 likes. And when Noor sees this post, he sees that there are 8 likes. Now you tell me, is it a bad situation to be in? Of course, no, that is fine. So the system is not really consistent, but that is fine. So we really don't need consistency. We definitely need eventual consistency, but we are not very reluctant on having the system highly consistent. However, on the other case, let's say Manav open the newsfeed and he is not able to see the newsfeed. That is a bad situation to be in. So we will optimize for availability as compared to consistency. So for the system like Instagram newsfeed, we need low latency. We need eventual consistency. We need high availability. And we definitely need partition tolerance, as our system is a distributed system, right? So this is about our design requirement. Now, as we are clear on what are we actually designing, we are clear on what scale we are designing, and we are clear on what design goals we have to keep in mind. Let's move towards actually design. So let's see the design deep dive in the step 4. Okay? So let's start. Let's start with the very first thing that we see in the storage requirement. We have 184 terabyte of data. Now you tell me, can you store all of this data into a single database? Is there any database that can store all this database? Of course, no, right? So we have to divide this database, divide this data into multiple databases. This is known as data sharding, where each of these database does not contain all the data. Each database contains part of data. However, together, all the DB contains all the data. This is what is known as data shard. So now tell me, how will you shard the data? How will we shard the data? One approach that we see that we can shard the data based on is we can shard based on timestamp. What do I mean by sharding based on timestamp? If we have 184 terabyte of data, we have different database. So the user which is uploading the data first will first get into this database, right? So this database will get filled. DB will get filled. Once this database will start getting filled, the next set of posts will start going to this database. Then once this also get filled, then it will start going into this database, then into this database, and then into this database. So we have sharded 184 terabyte of data based on timestamp. Now, what will happen if you are sharding based on timestamp? Let's say we are doing a query of get profile of, let's say, Rajat. So what is the profile of Rajat? On the profile of Rajat, you will see my photo, you will see my name, you will see some description, and then you will see a lot of posts, right? Post 1, post 2, post 3, 4, 5, 6, 7, 8, 9, and so on. However, when you are doing this, if your data is sharded based on timestamp, you tell me whether this will be slow operation or fast operation. Of course, this will be slow operation. Why? Because since you have sharded based on timestamp, some of my posts will be on database 1, some of my posts will be on database 3, some of my posts will be on database 4, some of my posts will be on database 5. So to retrieve all the data, all the posts in a single go, I have to retrieve data from multiple database, which is going to take time. And so the latency here will be high. But what is our design requirement? Our design requirement was that our latency should be low. So this approach will not work. Okay, let's move to second approach there. The second approach can be, let's shard based on user ID. What do I mean by shard based on user ID? If we have 184 terabyte of data and we have multiple databases, then one database will have data for all the data for multiple users. For example, let's say DB1 contains the data for Rajat, for Samriddhi, for Manav, and multiple others. The database 2 contains data for Noor, Aditya, and multiple others. Similarly here, right? That is how we are sharding the database. Now, what does it mean to have all the data for a single user? What data is Instagram storing? Definitely storing the profile details. By profile details, I mean name, email ID, phone number, date of birth, gender, these kind of details. Second is they are also storing the followers detail, people who I follow, right? People I follow, right? So let's say I follow Samriddhi, let's say I follow Manav, and multiple others. It also contains people that follow me, right? For example, let's say Manav also follow me, Noor also follow me, and these lists. And it also contains all the posts created by me. I have created post 1, I have created post 2, post 3, and etc. etc. So all the data that is for one user is stored in one database, and one database is storing details of a lot of users. Does this make sense? That is what I mean by shard by user ID. Now, if you take a look of shard by user ID, then now tell me, will get profile details be fast? It will be fast because all the details that you want, profile photo or name or description or all the posts that there are, can be retrieved from a single database. So get profile details will be fast, right? However, what about get newsfeed? How do we get the newsfeed? Right? How do you get the newsfeed? The very first thing about newsfeed is, let's say if I'm finding the newsfeed for Rajat, then the very first thing that I have to do is I have to find people that Rajat follows. Let's put that in a list. Let's say Rajat follows Manav, Rajat follows Samriddhi, Rajat follows Noor, and multiple other people. So this is one list, that the people that Rajat follows. Then I have to find recent post created by these people that I follow, right? For example, Manav might be creating post 1, post 2, multiple posts. Similarly, Samriddhi will be creating multiple posts. Similarly, Noor will be creating multiple posts, and similarly. Now, out of all of these posts, I have to find the top 10 posts based on some, of course, ranking algorithm. This ranking algorithm can be as simple as the most recent post, or can be more complex based on likes, comments, and something else. This is how the get newsfeed algorithm will work overall. Now, if you take a look by sharding by user ID, then this operation, finding all the people that Rajat follows, is cheap, is fast. Why? Because again, all the people that Rajat follows are here directly. So this is fast. But post, now some users, Manav data might be here, but Noor data can be here, or some other people that I follow might be in some other database. So when I want to retrieve the post for all these users, they might be in different database. So again here, to render to retrieve all the data for the news feed, I have to make multiple DP hops. I have to hit multiple databases, which will make this operation to be slow. And again, the news feed will become slow, and the get news feed will become, the latency for the get news feed will become high, which is against our design requirements. So what we do? So the solution to this is having a cache. Why? Let me talk about it. If you do a very quick observation, then news feed always contains recent data. Right? Newsfeed does not contain data that was posted 300 days back or 2 years back. Newsfeed contains data that is recent, maybe posted few hours back, or maybe posted 3 days back, 4 days back. So let's create a cache that stores all the posts posted in the last 10 days. Let's do an estimation of how large this cache will be. If you remember, the storage requirement per day was 50 GB. So what is the storage requirement for 10 days? It will be 50 GB into 10, which will be 500 GB. Is 500 GB big? No, 500 GB is not really that big. So you can store all the recent posts in a separate cache, in a global cache, which is not going to be very big, and store it there and then render your news feed from here. Does this make sense? If this makes sense, let's start creating the design. So of course, we will have the client. What is a client? A client can be a mobile device, a client can be a web page or something, right? Once you type here Instagram.com and press enter, what is the first thing that happens? The client goes to a DNS. What is a DNS? If you don't know what is a DNS, we are going to upload a video on very, very common and basic terms of system designs in another 2 to 3 weeks. So you can stay with us and watch that video, in which we will cover very, very basic terms of system design, like CDNs, like DNS, like latency, and others. However, a DNS takes a domain name and returns the IP address of the machine, of basically the load balancer. The client then hits the load balancer. Then here there is a machine layer. Then below that there is database layer. This database layer is sharded by user ID, as we were discussing. So let's say, and then there is a global cache here as well. Global cache, which contains recent 10 days post. Let's say if someone is retrieving get news feed for Rajat, then how will it work? First, it will of course go to the DNS, returns the IP address. Then the client goes to the load balancer. Then it goes to one of the app servers, machine layer, or you can say app server layer, whichever you want, whatever you want to say it. Then the machine takes it to one of the database which contains the data for Rajat. How does the machine know which database contains the data for Rajat? It uses an algorithm known as consistent hashing. Again, what is consistent hashing? We will cover that in the basics video. You go to the database which contains Rajat data. From here, this database returns all the followers, all the people that Rajat follows. So this returns people Rajat follows. Then this machine with people that Rajat follows goes to the global cache, then retrieves the recent post from all these people and comes back to it, and then it will filter and then send the result back to the load balancer and then to the client. So this is how your get news feed will work. Now there are two things that you should keep in mind. One is when you are talking about this global cache, then how do you populate or basically add post to this cache? And second is how do you remove old post from this cache, right? So how do you populate is whenever someone is adding post, right? Whenever someone is adding a post, you definitely add it to the database, but you also add it to cache, right? And how do you remove old post? Either you can have a expiry whenever you add to cache, keep a expiry of 10 days, or you can have a background task running that cleans your cache every now and then, right? So this is how you can design Instagram news feed. This was about today's video. I hope you liked the video. Again, if you like the video, please hit the thumbs up button and also subscribe to our channel. We are going to post a lot of valuable content on system design. So stay tuned.